Hello, I'm Carlos Chavez. I'm a student at Burges High School and also El Paso Community College. Today we will try to make sense of the universe with my final project for my astronomy class. Today I will be teaching over the laws of motion that rule the universe, gravitational laws, and energy. I will start the video with describing motion and its properties, then the Newton laws of motion, momentum, the universal law of gravitation, and finally explain the orbits of planets as well as their tides. So now, let's begin with 4.1.
How can we describe motion? We can describe motion as changes in an object's position or over time, and can be characterized by its speed, velocity, and acceleration, and also direction. Its speed refers to how fast it is moving, or the rate at which the object or objects are moving, which can be calculated by using distance in meters and time in seconds. It's just distance over time. And velocity is the same equation as speed, but direction matters. And acceleration is if you're speeding up or slowing down, or basically the rate of change in velocity. What about gravity? Gravity is a fundamental force by which an object, or planet in this case, draws objects towards the center. The acceleration of gravity explains how a fallen object is accelerated at the same rate, which is 9.81 meters per second squared, without counting air resistance and friction. Something relevant that we should know is how mass is different from weight. Weight is a force, in this case, the force of gravity acting on an object. And mass is a quantitative measure of inertia. Mass is a scalar, while weight is a vector. With this in mind, you could conclude that we erroneously confuse the meanings of weight and mass. So that's gonna be it for 4.1. So now let's move on to 4.2.
Welcome to 4.2, the Newton's laws of motion. First of all, how did Isaac Newton change the world? Newton's laws of motion and universal gravitation, along with his invention of calculus, which I know everyone loves, fundamentally changed the way scientists understood the universe and how it works, while realizing that the same physical laws that operate on Earth also operate in the heavens, which is just another way of saying this, the universe. In this lesson, we will explain the three Newton's laws of motion. In the first law of motion, Newton explains the law of inertia, which means that an object moves at a constant velocity unless a net force acts to change its speed or direction. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This equation is expressed as this one, which is force times mass and acceleration, where F is the force, m is the mass, and a is the acceleration of the object. Finally, Newton's third law of motion explains that for every reaction, there's an equal and opposite reaction. As simple as that. Alright, now I will show you a physical model that displays a representation of the three Newtonian laws. Okay, so now here's the model. As you can see, I divided this model into three different sections, where each section explains each different law, and I'll start with the first one, which is this one. First law of Newton, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion. Here's a representation of the first law, which is a car that it's just a movement, which is applied by friction. Friction, the force applied, friction that is stopping it, the force of weight, and normal force that is applied here on the top, as you can see. In Newton's second law of motion, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So basically we can state that if mass is always constant on the system, the more force you apply on the object, the more the object is going to accelerate, as explained here in this little model, with the arrows explaining which force is acting on it. In this case, normal, friction, and weight. On the third and last law of motion, for every reaction there's an equal and opposite reaction. Just as simple as that. For example, in this collision that I illustrated here, this car the one that has a bronze color, will move to the left, and the green car will move to the right in case of a collision. But it also depends on their masses and their velocities. Okay, so this was my model for 4.2, and so now let's move on into 4.3. Hi, welcome to 4.3, and this lesson is about conservation of momentum. And as explained before in the first lesson, if there's no net force acting on an object, momentum will stay the same. In this lesson, I will explain what angular momentum is and its basics. The angular momentum of an object cannot change unless an external twisting force named torque is acting on it. The equation that represents angular momentum is this one, where L is angular momentum, M is the mass of the object, V represents the velocity of the object, and R represents the radius or distance from the axis of rotation. Planets follow these rules and keep orbiting the sun because of conservation of angular momentum. The common question is, where do objects get their energy? First of all, energy cannot be created, neither destroyed. Energy makes matter move and is conserved, but it can transfer to one object or another, or convert from one to another. Energy can be categorized in many ways. The most relevant ones in this lesson, or in all lessons in astronomy, will be potential energy, which is like stored energy, and kinetic energy, which is the energy of motion. Essentially, there are other types of energy, like chemical, thermal, nuclear, mechanical, and electrical, but these are not going to be really relevant in this class. So that'll be it for 4.3. So now let's move on into 4.4. Hi, welcome back to lesson 4.4, the universal law of gravitation. Newton's law of universal gravitation describes gravity as a force by stating that every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers of mass. The equation that represents this law is this one in here, which is force of gravity equals the universal constant times the mass of the two objects multiplied and divided by distance squared. The value of the gravitational constant is 6.67430 times 10 to the negative 11 power. Newton's laws of gravity and motion show that the relationship between orbital period and average orbital distance of a system tells us the mass of the system. Be it for lesson 4.4, so now let's move on into lesson 4.5, which will be the last one. So now we're in the library and we're gonna see what is lesson 4.5 about. In this lesson, we will explore the orbits of planets, their tides, and the acceleration of gravity in a large scale. A way to describe the change between potential and kinetic energy is that when the planet is the farthest from the star it's orbiting, which is the aphelion, if I'm sure, the star orbits slow. But if it's at its perihelion, which is the point at closest to the sun or the star, the planet will orbit faster. The explanation behind this is for the planet to cover the same amount of the same area on the same amount of time. Something we should also discuss in this video is what is escape velocity. Escape velocity, or escape speed, is the minimum speed needed for an object to escape from contact of an orbit of a primary body. This is gained with enough orbital energy, and it changes from bound to unbound orbit. For example, the escape velocity from sea level is 40,000 kilometers per hour, which is equal to 11.2 kilometers per second. You will not believe me if I tell you that the moon is responsible for the ocean water levels and the regulation of our climate and seasons. They're called tides. Tides are the rise and fall of sea levels caused by the combined effects of the gravitational force exerted by the moon, and to a much lesser extent the sun, and all are also caused by the earth and moon orbiting one another. So that was it for 4.5, so now let's move on into the conclusion. So we're at the finish line of this video. We have learned that what is motion and its properties like speed, velocity, and acceleration, all these types of forces and energies that rule the world and the heavens, the conservation of momentum and angular momentum, the universal laws of gravity, the orbits and the tides that come with the gravitational pull of the moon to the earth. I hope you liked this video. We have explained some of the gravitational rules that govern the universe, so now my final project comes to an end. Goodbye and have a good one.